Good morning, good afternoon, or good evening, cloud experts, depending on where you are. I hope you all are healthy. Today I am planning to cover AWS Database Services. In today's topic, we will start with how application evolved over time and how the data storage changes evolved over time. I have used multiple diagrams, animations to explain the concept. If you follow today's session without skipping any content, you should have a complete understanding about AWS database offerings and what database service you should choose for your use case. Before I start, I would like to request you, if you are new to our channel or haven't subscribed yet, then please subscribe to our channel and please click on the bell icon to get notification for any new topics. We are trying to upload videos on a daily basis or at least 5 videos in a week. Let's get started. We'll start with application architecture evaluation. If we go back in 60s or 70s, mainframe was a predominant way of building applications, and that lasted until 80s. When client-server architecture was introduced and significantly changed the way applications were built, apps started to become more distributed in nature. However, the underlying data model was predominantly structured and the database was monolithic. As you know, internet arrived during 90s, and as a result, client server architecture evolved to a three-tier application architecture where we segregated application layer and web layer differently, and we tried to build more and more internet exposed web applications. Client and application code became more distributed, yet the underlying data model was still structured and predominantly monolithic. This is how it worked till 2011, before microservice architecture was introduced. We broke the monolithic applications into small modules. We are creating application for every services, and as a result the underlying database is also changed. Nowadays we are not using a single database. Based on that requirement, based on the use case, we are choosing different databases. I am going to discuss all different types of databases along with the use cases. But before that, let's try to understand the effort when you are hosting an application database in your data center versus when you are choosing a managed service. When I'm talking about self-managed, it could be you are hosting the database in your data center, or it could be in EC2 instance in AWS cloud. Both will have similar type of effort. In the left hand side of the diagram, you can see the stack of responsibilities. If you are using self-managed databases, then all the responsibilities are yours. You have to manage starting from routine maintenance of the application server to schema design. You have to take care every task. On the other hand, if you are using fully managed database service, you are giving the heavy lifting work to cloud provider, in our case AWS, and you are only working with schema design, query construction and query optimization. Now let's try to understand the different category of databases. First, we can break the database category into two. One, transactional databases or OLTP, online transactional processing, and on the other hand, analytical database or OLAP, online analytical processing. In transactional databases, we are trying to handle transactions. On the other hand, in the analytical database, we are trying to find the facts, or we are trying to find hidden facts out of the data. Using analytical database, we are generating predictive and prescriptive analytics or prescriptive recommendations. Now let's understand what are the databases under every category. If I go with transactional databases, we have main two categories, relational and non-relational. If I'll start with relational database, AWS provides two different categories here. First is RDS or Relational Database Services. In terms of database engine, you can go either with MySQL, PostgreSQL, MariaDB, Oracle, SQL Server. Oracle and SQL Server are the commercial database engine options, whereas MariaDB, MySQL and PostgreSQL are the open source database options to choose as RDS database engine. Most of the cases we found in on-premise also we are using any one of the database engine. When you will move to AWS cloud, either you can carry forward the database engine you are using in your on-premise, or you can go to more cloud native. And when you are talking about cloud native, it is Aurora. Now RDS also supports Aurora. Aurora is AWS proprietary database and it has a altogether new concepts. I will create a different video only specific to Aurora. Now in terms of database engine, as of today, Aurora supports MySQL and PostgreSQL database engine. We also have Aurora serverless. Now serverless means you are really not managing any database servers, or you really do not have to think high availability, or you really do not have to think about the scaling up or scaling out, or scaling in or scaling out. Coming back to non-relational, first DynamoDB. Again, this is AWS proprietary database and this is a key value pair database. I have a dedicated site to talk about each and every databases and the use cases. Next is DocumentDB, then Elasticache, Neptune, TimeStream, Keyspaces and QLDB. These are all AWS non-relational database offerings. If I go to analytical database processing, it starts with Redshift. Now Redshift has two different flavors. Either you can go to Redshift node or you can go to Redshift serverless. Like Aurora serverless, you are not really managing any Redshift node or you are not managing high availability here. AWS will manage for you. Then we have Redshift Spectrum. Again, Redshift Spectrum is serverless and you are really not managing any node or any server here. And the last is Amazon S3. Although S3 is an object storage, but S3 has many AIML capabilities. And S3 can store any format of data, any volume of data. It can virtually store any amount of data for you. S3 will reduce the data storage cost for you and you can integrate with other analytical services with S3 seamlessly. In summary, AWS offers a broad range of database services that are purpose-built for major use cases. Now let's understand what are the use cases and when you should use what database. Let's start with relational databases. Now as you know, relational databases support ACID compliance. You have schema on write. That means you have table structure. You have relationship between the table. You can create join queries. And as I mentioned in the earlier slide, you have the option to go with RDS or Aurora serverless. Now what is the common use case? Normally if you have a database in your on-premise application, maybe you are working with MySQL or PostgreSQL or SQL Server or Oracle and you want to migrate your database into AWS as part of lift and shift mechanism, then RDS is the best option for you. After that, you can convert your database into cloud native. But RDS or the relational databases, if your application requires join queries, then relational database is the option for you. Moving to key value. Now this is AWS non-relational database offerings. This is ideal for real-time gaming, bidding application, shopping cart, product catalog, or even taking customer feedback. DynamoDB can offer and it can support unlimited throughput. Next, DocumentDB. Maybe in your application demands to store JSON document. You can store the document quickly and access those and access any attribute of the document. Then the option is DocumentDB. Now DocumentDB is MongoDB compatible. In your on-premise or in your data center, if you are using MongoDB, you can migrate your application to DocumentDB. The use case would be content management, personalization or mobile applications, or in your application if you are trying to process JSON documents or storing JSON documents. In-memory databases. If you have an application where requires caching, maybe you are generating a leaderboard, or maybe you are generating a real-time analytical application, or maybe you are creating a video game where you have to cache the data. Elasticache is the option for you. Amazon Elasticache comes with two flavors, Memcached and Redis. You can choose whatever is applicable for your use case. Using Elasticache, you can achieve microsecond latency in your application. And again, this is only applicable when you have a requirement for caching. Then graph. Use case would be fraud detection, social networking, or recommendation engine, or even in lately, many organizations they try to find out the COVID tracing, especially all the life science and health organization. Maybe a person X, he visited city Y or he met with his friend Z. In that case, who are get affected? Now, if you are using a SQL based database, at least I will not try to write that query. You can easily create a graph based relationship with Neptune. Next, time series. Maybe you have an application where you are interacting with an IoT device and where you are storing a time stream of database. When you have a use case to store time stream data, that means to collect, store and process data in sequence by time, then time stream is the option for you. Next, ledger. Ledger are typically used to record history of economics and financial activity in an organization. Many organizations build applications with ledger-like functionality because they want to maintain an accurate history of their application data. For example, tracking the history of credit and debit in banking transaction, verifying the data lineage of insurance claim, or tracing movement of an item in a supply chain network. These are all examples of ledger data. When you have a requirement for ledger data, then QLDB or Amazon QLDB is the option for you. Next, wide column. For applications that require high-speed data processing with single-digit millisecond latency, such as industrial equipment maintenance, or maybe trade monitoring, or maybe fleet management, for those use cases, you can use Amazon Keyspace. Amazon Keyspace is a serverless, so you pay only for the resources you are using. Now, Amazon Keyspace manage Cassandra database. If you have any use cases like that, Amazon Keyspace is the option for you. Now we came to a conclusion about today's topic. I hope I was able to clarify all your doubts. If you have any question regarding today's topic, please post your question as comment to this video. We will answer at earliest. Before we conclude today, I would like to request you please subscribe our channel and please click on the bell icon to get notification for new topics. If you want me to cover any topics, please provide your request as a comment on this video. If you appreciate our effort, please like this video. It will definitely motivate us. At the end, thank you. Please take care and stay safe.